Good afternoon, everyone. My name is Mark Dirks, and on behalf of ACRL and Choice, I'd like to welcome you to today's program, Strategies for Addressing Students' Comprehension and Visualization Needs, Integrating Interactive 3D Tools into Human Anatomy Courses, which is sponsored by Gale, a Cengage company. Today's discussion is one in a series of sponsored webinars from ACRL and Choice that addresses new ideas, developments, and products of interest to the academic library community. Free to users, these structured 60-minute live presentations provide the opportunity for interactive discussions of important new issues and developments in academic librarianship by librarians, vendors, authors, and other interested stakeholders. Before we get started, I will just point out a few features of the webinar software. In the main area of the screen, you should be able to follow along with the presentation materials. Along the right-hand side, you should see a Q&A panel and a chat panel. If you don't, you can click the button with a dialog cloud and the button labeled Q&A at the bottom of your screen to activate the panels. If you don't see the Q&A, it may be under the three dots there next to the chat button. Please use the Q&A panel to submit your questions to our speakers, and at the end of the presentation, they'll take a few minutes to answer those questions, so please do send them in throughout. If you're experiencing any technical issues, that's what the chat panel is for. Please use it to let me know, and I'll troubleshoot the issue with you privately. Today, we are using the hashtag ACRL Choice webinars, so if you've got another screen handy, feel free to shout out to us. We're at choice_reviews. Also note that we are recording today's program, and everyone who registered should receive a follow-up email with a link to the archived version at some point in the future. Our speakers today are Dr. Darren Hoffman and Amy Braun. All right. And Dr. Darren Hoffman received his PhD from the University of Iowa in 2006. He's currently the assistant professor of anatomy and cell biology at the University of Iowa Carver College of Medicine, where he teaches gross anatomy to medical, dental, and other health professional students. Dr. Hoffman is the recipient of numerous teaching awards and is known by his students as an innovator in medical and anatomical education. He conducts research in these fields and has recently published a report on the use of 3D anatomy technology to transform a dissection laboratory. Amy Braun is the Product Management Director responsible for building academic business and science products at Gale, a Cengage company. Creating dynamic tools and content to help students succeed has been her mission since she began it as a Gale editor 12 years ago. In her product director role, Amy is focused on sharing the power of the Gale Interactive line of products with STEM librarians and faculty and finding ways to build more products that customers love. And with that, I believe we are ready to get started. So I'll pass the ball over to you, Dr. Hoffman.
Thank you. So today I'm going to talk about 4 different aspects of this technology, and I'm going to start by giving a little bit of context about what modern anatomy education is like, and then I'll demonstrate the Gale Interactive Human Anatomy product by showing you an example session where we're going to dissect the pancreas together. And then I'll talk a little bit about some recommendations for how to integrate 3D anatomy into a modern anatomy curriculum. And this might be helpful information for you to use when you're talking to faculty in your colleges about how they might use these new products. And then I'll finish by talking a little bit about an educational research study that Mark just mentioned where we use 3D anatomy to transform an anatomy course. Starting off, we're just going to talk a little bit about the opportunities and challenges in anatomy and health sciences education, and to do so we have to talk about what anatomy is. It is a very old subject in medical education, as this painting from Rembrandt suggests. This sort of idea of dissection is often what people think of first when they think of gross anatomy, and that's for good reason, because dissection is a really compelling and almost one of the best ways to learn anything about how something works is to be able to physically interact with it in this way. And oops, sorry about that. The process of dissection as a learning modality hasn't really changed that much over the years. These are images, these are some students from the University of Iowa around the turn of the century. And about the only thing that's different from the Rembrandt painting is it's the students who are doing the dissection by the time we get to this period of history. And that has to do more with better fixation chemistry that allows the students to do the work. And then, of course, if we look at modern medical students, these are from the University of Alaska, it's essentially the same process. The student population is more diverse, but we're still doing the same old dissection process when we're working in anatomy labs. Technology has obviously infused modern medical education. I'm sure many of you work with lecture recordings and broadcasts to allow students to engage with courses outside of the typical classroom space. Clinical simulations are, of course, everywhere. You may have simulator models like this. This one on the right, his name is Harvey. We have him in our library. He's an excellent cardiovascular simulator. And, of course, clinical data and imaging are easier than ever to bring into our instruction, and we can bring in actual clinical data in real time into our instruction. So there's really been a lot of revolution level changes in medical education since I got my PhD almost 20 years ago. So the modern anatomy classroom is also undergoing lots of changes. You may have seen or interacted with something like the anatomage table, which has a virtual body inside of it that students can interact with. It's essentially like a huge touchscreen iPad. Or like these 3D syndavers. These are synthetic cadavers that have many of the structures of the human body with some faithful texture representation. And of course, what you see over on the right here is the use of a 3D anatomy app in the gross anatomy lab happening at Toro. And these 3D anatomy visualizations are becoming increasingly prevalent. And if you just browse in the App Store, whether you're on a Google device or an Apple device, you're going to see tons and tons of 3D anatomy apps that are out there where students can interact with 3D anatomy. And these are being directly marketed to students. And one thing I uncovered when I started working with these apps and doing a study of them was that the quality is highly variable. There are many apps that are really just not that good. And this, I think, presents an opportunity for us as faculty or librarians to make sure that we're providing resources to our students that we know are good and that have built-in pedagogy. Many of these apps are essentially just a model with zero instructional support. So a student can spend a lot of money going app to app before they find one that's any good, and we might be able to save them some of that time and money. So some of the challenges that we have in anatomy are that in some dissections just work better than others. We know that when we have first-time dissectors working on a region like the pelvic floor or maybe the sole of the foot, these are particularly difficult dissections. They often don't go that well. Dissection also is not necessarily an option in much of the world. We very much take for granted in the United States that dissection is a normal part of medical education, but that's not always true depending on cultural practices where bodies need to be buried within a certain amount of time after somebody dies. When I'm lecturing about anatomy, I'm sure you would imagine that the structures inside of your body are not all flat and linear. So they're all arranged in complex three-dimensional relationships, and often these three-dimensional relationships are incredibly important for medical reality. And often for me to talk about those 3D relationships, I end up having to show multiple flat images in succession and each time orient them to the different views that are being used, where if I just had a 3D model and I could just turn the model, it's an instant recognition of what has happened in the student's mind. I think the third area where we can make the most impact with in anatomy education is how we are present in the at-home study environment. I really believe that the majority of learning in medical school doesn't happen in our classrooms. It happens in our libraries, and in the students' apartments and in coffee shops, where they're really doing the heavy lifting and working through the big ideas and trying to make them stick. So, I know from my experience working with first-year medical students or working with undergraduates that these students often struggle with the self-regulation process that's necessary to work with this much information. And students frequently will default to the memorization strategies that were successful at getting them into college or getting them into medical school. Unfortunately, anatomy relationships are just incredibly complex. There are tens of thousands of pieces in the human body, and they're all interacting with each other in different ways. And it's just impossible to learn that kind of information by memorizing it. You have to operate on a different level of understanding, and you have to be able to almost close your eyes and see in your mind's eye what it's going to look like. So I think if we could help students bridge that gap, I think that's an excellent opportunity to make medical education a little bit better. So I'm going to jump out of the slides now and just give you a quick demonstration of a 3D anatomy session. So I need to quick share my screen so you can see what I'm seeing. So now we're looking at a specific session that's been built to describe the anatomy of the pancreas, which is going to be a common subject whether you're working with undergraduate students or with medical students or dental students. Everybody needs to learn about the pancreas. And I'm just going to maximize this so that we can all see everything. Amy's going to talk a little bit later about some of the other things you saw on that main screen, but we're just going to talk anatomy for a minute. So as you can tell, the pancreas is sort of a hidden structure. It's tucked away behind the stomach there, kind of hooked in the C-loop of the duodenum, but it's buried in that abdominal space, and that's critical because that means the pancreas is very difficult to operate on. So while a student is looking at this session, you'll see along the bottom there's a series of buttons. This indicates the keyframe slides that are present in this particular session. A student can navigate through them by just clicking on them, or they can use the arrow buttons that'll kind of advance them through the slides. You'll see that at each slide there's on-screen text that describes and orients the viewer to what they're trying to get out of that view. Often there are prompts that will get them to think about, like in this example, the pancreas. It's important for students to know what vertebra level the pancreas is at, and in this case it's the first lumbar vertebra. If you sort of turn the model, you'll see that the first lumbar vertebra is behind there. It's important for students to know that because that's how they're going to find the pancreas on a radiograph if they're looking at a CT scan. So you'll see in the on-screen text it prompts them to make that observation. And it's also important to understand that students have the ability to manipulate this model at any time when they're working in the session. They can pull objects apart if they want to. They can spin it, zoom it, work however they want to go. And if at any time they feel like they maybe screwed it up too much to recognize what it is supposed to be, they can just click that button again and it'll go back to that kind of preordained key view. You'll see that the pancreas is in close proximity to those major blood vessels back there. In addition, these large arteries that supply most of the GI tract with blood are almost embedded into the surface of that pancreas, making it very difficult to do surgery on. Often, pancreatic surgery results in injuries to the spleen because it is in such close connection. And then there's our stomach and our duodenum, virtually wrapping the pancreas completely. So you can imagine this is a difficult thing to operate on. You could also imagine if you're in a gross anatomy course and you're being asked to evaluate or find the pancreas, there's only one way to do that, and that's to get everything else out of the way. And that is a very time-consuming, difficult process. And often by the time you get down there, a lot of things have been changed from the way they naturally were, which makes it difficult to build those connections back up. At the end of each session, there's a series of review questions that will encourage the students to apply what they just learned. So in this case, which of the three structures shown here is the head of the pancreas? If you were paying attention to the session, you would remember that that is A. This is a multiple choice question that talks about inflammation of the pancreas. If the inflammation is superior, what is going to be in the way? Then the last one question here is a click-on question, where the student actually has to click on an object. So which vertebral would be expected for the pancreas? Click on the right vertebra. If you remember, it was that first lumbar vertebra, and you click on that, and you get to go to the last question, which is a label matching question. So in this case, you'd take labels and you'd associate them with the correct structures on the model. So you can see that the sessions are dynamic. They allow students to interact with the anatomy in real time, and there's also some sort of built-in pedagogy and review that allows the students to confirm they've gotten the correct objectives. Okay, so I'm going to stop sharing and go back to the PowerPoint, and we'll talk about how we might integrate these resources into a modern anatomy course. So as I mentioned before, I kind of see that there's opportunities in lecturing, in laboratories, and most importantly in at-home study. So I'm going to talk about all three of these different areas as we go through. In the lecture hall, I've found that these 3D visualizations are particularly useful in two places. They are very useful at the beginning of a lecture when you're presenting a region of the body that is completely new for your students. This image you see on the left is a good example. Most people have never considered what's happening inside of their nasal cavity. It's not a region of their body they're familiar with. So spending a little bit of time orienting the viewers or your students to what these things look like visually in the big picture is a really nice place to start. Another great place to use this is using at the end. So this is if you have worked through a complex topic in multiple layers where you've talked about muscles and then you've talked about arteries and then you've talked about nerves, it can be nice to run through a simulation that shows the students how they're all integrated together in the big picture. And I have found that this often saves me time when I'm lecturing. This allows me to explain topics in much less time. If I'm doing that multiple view thing, when I'm doing the pelvic floor, if I just have that 3D model and rotate it, it's almost an instant benefit. In the laboratory, you could certainly, as you saw in the image before, you could utilize these models and these sessions as table-side dissection support. So students could be actually working with the models while they're dissecting, using it as a guide. We currently, in our courses, we have paper-based atlases in our laboratories that all end up having to go in the garbage at the end of each course because they get ruined by the fluids that are in the laboratory. So imagine the tremendous amount of waste and resource as we consume all of these books, whereas this could be done electronically using tablets or table-side laptops. You can also use it in laboratories where you have computer monitors that would allow you to project images onto the screen. This would allow you to do some of that just-in-time instruction. Say if somebody found something interesting, you could do a quick recap of what that structure is supposed to look like and compare it with that interesting finding on the donor. And then lastly, at home, I feel like this is the area where we have the most potential, and it's also where people seem to be the least familiar with how to make inroads. So I think I'm going to talk about 4 different levels of integration of this sort of technology for at-home study. There's sort of increasing levels of integration. So all the way from the very casual integration all the way to the full-blown level of integration. So let's start with minimal. So if you're not comfortable with the idea of fundamentally transforming what you do, the least you can do is show students where the resource is available in their library. And so this is something that we do absolutely for sure. It's just to show them where they can find these links. And we've incorporated the links into our other course websites and resources. This definitely attracts your early adopters, people who like technology. They might get enthusiastic about this, but that's probably about it in terms of who you're going to immediately attract using this approach. If you want to go this route, you have to at least demonstrate the resource in class, show them why it's useful, and provide some sort of explanation of when they might consider using it. If you want to go a little bit further, you could take specific examples of sessions. So in this case, you can see this is my lecture handout for a lower limb lecture that I do. And in this lecture, I have a recommended reading from a textbook, but I also have recommended viewing or interaction with the human anatomy sessions and I've listed them out here. These are the sessions I think they should work on. So it's similar to the assigned reading idea that we all probably grew up with when we were in college. It definitely, again, attracts your early adopters. It attracts your rule followers, those who are trying to do everything you suggest. And I think it's wise to explain how this resource is different than a textbook and how the two different resources might be useful in separate ways. But you still might run into the problem that many of us are aware of, that often students don't do the recommended reading, so they may not also do your recommended viewing. So maybe we want to go a little bit further. So in this case, I would recommend that you actually make it count. So to do this, you need to eliminate in-class instruction on the basics of a specific topic and instead assign the students to use the resource to fill that gap. And what you see here on the left is a worksheet that I have students work on their own. It's a self-study module. And in this particular worksheet, I have them working through two specific sessions that I think they can certainly gather the information on their own. That allows me to spend my class time with a little bit more literacy on the topic. So it's kind of a way of making them do the pre-reading because I'm not going to cover this material in class. And everyone will have to do it, so it's going to attract them. And you'll probably get some complaints from students who say you're not making it easy for them because they can't just show up and sit in class. Best practices for this would be same as everything I've said before. You got to demonstrate it. You got to talk about how to use it. You should probably clarify what your expectations are. When should this be done? How long is it expected to take? And really important is don't reteach the material. If you've given them an assignment and then you just reteach it later, they'll know forevermore that they never really have to do the assignment. And you know, if you're unsure, you want to just put one toe in the water, just do one section of your course this way and see how it goes. In my experience, it went a lot better than I thought it was going to go, and it allowed me to kind of break down the barrier and incorporate it into more places. The last thing you can do with this sort of a technology, or really any technology innovation, is you can totally change your curriculum. And I can use 3D anatomy to move to a more flipped approach. And so I've identified topics that, you know, I don't think are necessary for me to say to students if they can learn it on their own. And then I can use class time for more engaged activities. So, for example, I've got some drawing exercises that we do in class. These are animated drawings that I would have students do with me where we're drawing neural circuits. Before we would do this in class, the students would have viewed some of these nerves in the model, so they would know the big idea, but now we're going to get into the nitty-gritty of the wiring of the whole system. Or like the picture you see on the bottom, that is actually just a drawing that I made, and I put a bunch of numbers on it, and we have a contest in class to see who can label all 15 of the labels the quickest and the most accurate. So it can be fun. You can add some additional elements of fun to your class. You can certainly just do practice questions with your class time. If you've covered this, that'll ensure that they've gotten it to the right level. But I think one of the best things you can do is help students to pull information together across multiple lectures, bringing those big ideas all together in synthesis and integration. So the last thing I'm going to talk about is the research that I've done using 3D anatomy to change an anatomy lab. So this is probably most relevant to those who are working in places where there are currently anatomy labs going on. And this is a journal article that was recently published, and also some data that was presented at the American Association of Anatomists meeting in 2017 that's getting prepped for publication now. So our problem that we discovered in teaching our students was that they often came to dissection lab underprepared, both in terms of the techniques that they were going to be doing and the anatomical knowledge or expectations about what they were going to see. So we had to spend probably about half an hour-ish with passing time on just preparation for the pre-lab, or preparation for the lab. So we would have 20 to 30 minutes in a lecture hall just talking through the process, what anatomy they're going to see. This seemed like an opportunity. If I could just find a way to do a better job of them preparing on their own, we could eliminate that completely. So we did an experiment where we provided different types of pre-lab materials that were all improvements from what we had given them before. Previously, when we had the pre-lab preparation, we just gave them a reading assignment from the dissection manual, which unfortunately just didn't really work that well for the students, which I think is why we had to do the pre-lab. So in this situation, we provided 4 different types of resources. We provided 3D anatomy videos that were created using the software that you saw. Dissection videos, which are actual just videos of dissections. Both were narrated in a similar fashion. Abbreviated instructions, so we took the dissection manual and boiled it down to maybe 10 bullet points, and then some key figures from the anatomy atlases that we use in our courses. And then we just got rid of the in-class pre-labs, assuming the students would, self-direct through these different types of resources. We did make them do a pre-lab quiz to ensure they were ready. And then we rescheduled that class time for something more interactive and engaging. And we wanted to investigate which resources do they choose, which do they prefer, what are the learning outcomes, and how do the faculty feel about it. So this briefly describes, the precondition where we had a pre-lab for half an hour, we had a 2.5 hour dissection period, and then students would peer teach for half an hour at the end. We did a needs assessment survey of this last group of students in this cohort, and the majority of them indicated they needed better preparation resources, and this sort of sealed the deal that we needed to take on this challenge. So in our intervention cohort, we got rid of the pre-lab, as you can see. That allowed us to shift the dissection period forward to 8:30, and then that gave us 30 minutes at the end of our session to do some sort of advanced integration activity. It could be something as simple as doing a pin test in the class, or it could be doing some sort of case analysis and using their cadaver as an objective study related to the case. So it varied depending on the activity. We asked these students who are in this cohort how much time did they actually spend on their pre-lab preparation, and what we found out that it was almost exactly the same amount of time as what we were spending live. So it seemed like an even exchange of effort and time. So looking at resource preferences, we had students evaluate the 4 different resource types on an importance scale, meaning how important were these resources for your laboratory dissection work. And we found that the 2 resources that were the most popular for the students were the 3D anatomy videos, the bar on the top, and the key atlas figures. And the other 2 resources were significantly less than those. And the dissection videos, interestingly, were the least popular. And when we sort of dug a little deeper and asked students, why do you have this preference, what we found was the 3D anatomy videos visually were much easier to learn from than the dissection videos, because the dissection videos are all kind of shades of brown or shades of yellow, whereas the 3D anatomy videos, as you saw earlier, are very vivid colors, very easy to see the anatomical relationships on that stylized image. And importantly, that stylized imagery is also an important feature of key atlas figures. So those beautifully done atlas renderings are also done in a way that's sort of hyper-real, where the colors are enhanced. And I think that's a big part of what students like about it. They also talked about the importance of these 3D anatomy videos as preparation for their dissection and as preparation for taking tests later on. And they really liked that they could see these anatomical relationships that they were going to discover during the laboratory. So then, of course, we wanted to look at learning outcomes and how these two different student groups performed on similar tests. Almost no difference on the first two exams in the course, almost identical results, almost kind of uncanny how similar the outcomes were on those first two exams. But when we looked at the third exam, we found that there was a significant increase in score in the students who were in the flip classroom situation where they had these additional improved resources. And if we break them out further and we look at, okay, so let's take all the students and separate out the students by quartile in terms of their final course grade, we find that the students at the bottom in the bottom half of the class have less views of these videos compared to those who are at the top of the class. So this is definitely showing a strong association between use of the resource and academic performance. It definitely doesn't prove causation because it's entirely possible, and I would say probably likely, that high-performing students use more resources than low-performing students, but it is curious and presents the opportunity to investigate further about causation in the relationship between use of this resource and learning outcomes. So just lastly, talking about the faculty experience, I think that what I've heard from my peers and certainly what I've experienced for myself is that I enjoy spending my class time on more advanced material, that I don't really do lecturing anymore where I just read definitions or I just tell them, you know, this muscle is attached to this bone, this muscle is attached to this bone. I know that the students can learn that on their own if they have a good resource. So I get to spend my class and time talking about things that matter more and cases and, you know, problem solving. I also have more fun being creative with my class time. I don't have to feel like I'm just getting through the same lecture I've done 100 times. I also find that I have more time to teach things in the laboratory when my students are more efficient. So when they come prepared and they know what they're looking for, they can do a better job quicker and everybody's happy. It makes me feel like I'm making a difference, which is outstanding, and they seem happier as a result. The picture that you see on the left is from a class that I teach called Massage and Medicine, where I have medical students. They are learning some basic massage techniques and applying their knowledge of surface anatomy. And for each one of these class sessions, sort of done in a similar flipped style, where the students review their anatomy using the 3D anatomy simulations before they come to class, and so we can just jump right into massage practice when our classroom begins. So I think this is a big win from a faculty perspective as well. So I'm going to turn it over now to Amy, who's going to tell you a little bit more about the product and how it is set up and functions in the online space.
Thanks, Dr. Hoffman. So Gale Interactive Human Anatomy. Before we take questions, I'm going to spend just a few minutes reviewing the additional features. Gale Interactive Human Anatomy has 125 different activities, organized by system and by body region. Because these activities are self-paced, students who struggle can go through an activity numerous times until they're confident that they know it. And as you heard Dr. Hoffman say, he teaches at a medical school, but many first and second year undergraduates also take anatomy and physiology if they think they're going to go into healthcare careers. Your library can help students succeed in these challenging classes by providing access to these study tools. One of the things that differentiates Gale Interactive is its authoritative background information that corresponds to each slide within the activity. Though the interactives cover anatomy only, this content frequently details the physiology of the body part being studied, making it a great tool for combined A&P classes. Within that content, there are also corresponding images students can reference, like the X-ray of the wrist shown here. This helps to solidify the concepts as students can relate to the real-world application of the knowledge. In case you were wondering, some pathology information is also included in this additional material. The supplementary information isn't just limited to what we think will help them. When students have questions, they don't need to leave the product to find the answers. They can dynamically search right from within these activity pages. This searches the preloaded book and journal content included with the product and your Gale Virtual Reference Library ebook collection, adding additional value to the material you've already purchased. One of the questions we often receive is whether Gale Interactive is available on mobile devices. And yes, all of the Gale Interactive products have corresponding iPad apps, so students can walk through the sessions right from within the anatomy lab or even on the bus after class. If your library has access to 3D printers, there are also printable models available for over 60 different body parts. Students can print these body parts for further study. If you're interested in a free 30-day trial of Gale Interactive Human Anatomy, you can visit our website shown here. This is a subscription product, and your Gale rep will be able to draw up a quote for you. Now let's take some questions. So, first questions that came in, what was the name of the resource? And that is, I've said it now numerous times, Gale Interactive Human Anatomy. And Laura has asked, can you customize the sessions for your particular curricula or lectures? So the sessions are pre-built, so the students can walk through them on their own. So professors can't go in and build their own sessions. We just have the 125 that are there. Laura also asked, when Dr. Hoffman said, make it important, are you making it worth points? Dr. Hoffman, do you want to address that one?
I think I've done it both ways, where it's actually been a scored result where they had to maybe submit a post-quiz after they completed the assignment. I've also done it where it is just simply something you have to do, and it's essentially satisfactory, unsatisfactory if you complete the process. And I've also done it when I didn't actually require it. I didn't recognize it in points or gradebook at all. And if it is done well, I don't think you need to have the points, but often when you're just getting started, that's an important thing to be able to have that carrot to drive people to the resource.
And Laura also asked, do you find using these pre-lab materials improve their use of the dissector?
I think it does. It definitely improves their literacy with the visuals that are in the dissector. In my opinion, the text the written text that's in the dissector is written at a level that is beyond what is necessary for most first-time dissecting students, which is most of our students at the medical or dental level, certainly if they're undergraduates. But the visuals that are in the dissector are really valuable and important for determining where exactly to make cuts. And if they have that mind's eye kind of already built, they can interpret those images more successfully.
And Peter asked, did I hear you correctly that the platform has models for downloading and doing 3D prints? And yes, you did hear correctly. We have 65 different models that libraries can use to download and make 3D prints for students. The next question is, how is this product superior to others, such as visible body or the I can't say that word, anatomage table that you were discussing? Dr. Hoffman?
Sure. Well, so it's completely different than the anatomage table in that it's just the delivery mechanism is very different. The anatomage table is very limiting in terms of the number of students who can use it at once. You could have all of your students using this resource at the same time, even in a huge course, like the one I teach with 180 students, and they could all be using it at the same time. Some of the other 3D anatomy apps that are out there, like Visible Body or 3D for Medical, I saw that question pop up in the chat at one point too. Those are all very much in the same category of visual quality and anatomical accuracy. I've done a study this summer looking at all of the 3D anatomy apps that are in the marketplace, and this the engine that was used to build these is from a company called VivEd. And if you're familiar with the Netter Atlas of Anatomy, they also utilize the same models. So it's certainly in that, you know, upper tier of category for the 3D anatomy models. I would put it in the same boat as 3D for medical or visible body products. What's a little bit different is this product has a lot of built-in pedagogy with the sessions. The 125 sessions is actually quite a lot compared to some of the other products that are out there. And this product also exceeds the level of visible bodies offerings for the anatomy and physiology, which is definitely aimed more at the intro level. This product can function at the intro level and at the medical level.
Great, thank you. And Rita asks, does Gale provide a list of printable models on their website? And no, we don't have a list on there right now, but that's something that we can work on building and getting out there. Other questions? Does anything else come in through the chat?
Hello, this is Mark from ACRL and Choice. I just see that we've got one question that I'm happy to field there, in that we did, yes, record the webinar, and we'll make it available on our website, choice360.org, but I also believe that Gale will likely have a version available on their site as well, too.
And then Peter asked, Dr. Hoffman, are your colleagues also using this tool?
Yeah, everyone that I work with here at Iowa uses it with their classes. And I know several people from my associations with the American Association of Anatomists who are also utilizing this tool, and as well as others. There are the other software products that are out there. And I think that people are embracing this as an opportunity to make a difference for students in the online space.
Anyone else? Laura asks, do you ever see this as replacing the dissection laboratory?
That's a good question, and I love when this question comes up, because for me this is really important. This by no means is a replacement for dissection for me and for the work that we do at Iowa and many of the medical schools in the United States. It's really, there's so many things that you learn by doing a dissection that are both anatomical and also, you know, practical, emotional, spiritual. There's so many dimensions of working with a cadaver that you don't get by clicking and working with a virtual model in a web browser. It's just a completely different experience. But it is a fabulous supplement that really supports dissection and allows students to learn even more from that all-important process. So if your school is in a place where you're very happy with dissection, I wouldn't encourage you to think about replacing it at all. It's a great opportunity for students to learn, but you can even make it better by incorporating these types of technology.
Great. Any other questions?
I see there's a question about the National Library of Medicine's Visible Human Project. And am I right in reading that question? Is it from Judith, it looks like?
How do these models compare, with the Visible Human Project?
Yeah. So they're derived very differently. The National Library of Medicine's Visible Human Project was derived from a person whose body was scanned and sectioned after he died. And these models were generated using atlas images. So it's sort of a different sort of derivation. And pros and cons of each, right? The Visible Human Project has a little bit more, gritty reality to it because of their actual images of the human body. This is going to be more stylized, which could be a pro or a con. In many cases, those stylized images can be easier to learn from because you don't see the noise and the static that comes with working with real tissues. So very similar in terms of the level of detail that would be present in each, but it's just going to be a different visual quality because of the derivation.
And Adam also asked, does it integrate with Canvas? And yes, the activities do, professors are able to embed them into their LMS resources. So we've recently completed some LTI integration with a lot of our Gale products, and these activities do integrate well with Canvas. One more question from Laura. Are you planning on making a similar product with neuroanatomy, or is it already part of the product?
Well, I'll just clarify that it's not really part of the product. Typically when people talk about neuroanatomy, they're talking about the internal anatomy of the brain and the circuitry inside of the brain and spinal cord. The sessions that are here have, full anatomy of the peripheral nervous system and the structural anatomy of the surface of the brain and spinal cord, but it does not have internal anatomy of the brain and spinal cord. And I think that would be an awesome direction to go to develop some new technology, because that is an area that students really struggle with.
Yes, and we're always looking for new products or new needs that libraries have. So if neuroanatomy is a need, I know we've heard dentistry could be a need. We do want to continue to expand out the product line. Okay, another question came in. What about products like BodyViz and Sectra? I know completely different presentation, one being a table versus the other scalable to a number of devices and accessible. Any experience with those? And that question came from Andy.
Okay. Yeah, I've worked with the Sectra table before. It's similar to the Anatomage table. It's like a huge iPad. And it's great for if you have a setup in your laboratory where you have stations, because the table itself can be a station, and you can, basically choose what you want students to explore on that station by just setting up a particular model. So that's great. Again, it's the same issue as Anatomage. It's like limiting in terms of number of students who can work with it at one time. A single table is pretty expensive, so you'd probably be limited in terms of how many of those your institution could purchase, and so then that's going to limit the consumption by students. Whereas with a web-based product like this, your entire course could be using it at once. And I've done that in class, where I've just had everybody dial in and utilize the program to find a piece of information as we were working in class.
And a question came in from Lynn. Could this replace a human anatomy models collection in a library?
I think it's possible. We still have a boatload of models, both in our library and in our own classrooms in our anatomy department. And I have noticed that they seem to be getting used less and less the more these virtual models are available. So that's maybe a potential cost savings on the maintenance and repurchasing of models as they age. I don't know. Sometimes it's nice, though, to have one in your hands. I could certainly understand that.
Mm-hmm. Any other questions out there? How often are updates made, particularly in questions and exercises, to avoid redundancy from year to year? So right now, the sessions themselves are static, so we're not updating the questions that go along with them. It's something that we could look at doing, but we haven't heard that as a desire yet on these models. Any other questions? Are there plans to integrate any imaging like CT and MRI into the program, or is there already some of that in there? And that's from Andy. So as
there is some of that in there with the images that are from the Gale library.
Yes. And we would like to continue putting more images and things in with that content. Right now, we want to get the content into students' hands to continue to use through the library. And the more use it's getting, the more we can update it. Anything else? I think we're good.
All right. Well, this is Mark from ACRL and Choice jumping in again. And I would just say thank you so much, Dr. Hoffman, and thank you so much, Amy, for presenting this today, showing us all about this. It's really an incredible product, and I think I would just remind all of those folks listening out there that we did record the program, so you should be able to find that on our site. And I would also remind you that I would also encourage you, rather, to take a moment to fill out the quick survey that should be surfacing for you in the chat box to let us know how we did. We appreciate your feedback. And I would say thank you to everyone out there today for listening in and participating with us and asking some really great questions. I hope that you enjoyed this session and that the rest of your day is great.
Thanks, Mark.
Thanks all.